Alright. So today we will have two discussions. One lecture. So we can start with the discussion led by Lloyd. Okay. Let's go ahead.
Okay, so today I'll be doing the discussion section for the renewable energy lecture we had last week Thursday, though. Wait, Tuesday. Okay. And I'll just jump right into it. So how I'm going to structure this discussion is that we're gonna have a quick video review of the lecture of like one of the topics, and then we're going to do a discussion after each video. And it's going to be a Menti discussion. I'm not sure if you've ever heard of the website, but it should be fun-ish, hopefully. So, let's- uh, it's just like a companion thing for this lecture, and I wanted to present it here. Maybe I need to like log. Sorry about that. Sorry. Also looks like you, Michael. Okay, so for everyone, like on your phone or device, type in. Oh wait, oh, it's not there. Huh? You wanna do it? When I turn on my computer, the internet is installed. Influence. So minutes, and then after. That's the whole thing right there. So I go to the candidates.
순서가
네, 무슨 그림.
sequence. It takes time. Right. Then you can start the lecture. And to discussion. 사실 그런 알겠어. 자료가 문제가
무슨 무슨 말할 수 있는 할까요?
나도 이해한테 더 모르는 것이 있어. 그런 거막 나와서
Okay, finally, we're here. So on your devices, is it possible for you to log into mentimeter.com? Just type in the mentimeter.com and you're gonna put in this code.
for example, back that
MENTI.com.
web product.
Yeah. Yeah, we're gonna be able to. Oh, the number is
And you write down the board.
it's gonna be on the top of the screen. So it's 5882490.
5824900.
Yes. Is everyone in? Good. Okay. So I'm gonna just play the first video since I lost all the time. I'm gonna just kind of we have to speak through it. Okay.
It close the Zoom windows.
Zoom in?
Button.
Oh, okay. Thank you.
Right.
Okay. So now that we got that out of the way, the first slide is really easy. What is renewable energy? Renewable energy is just energy that is easily replenishable, right? And created from the environment. Okay. Just skip ahead to the video of wind energy. Offshore wind energy specifically. Is there audio?
What is like coming?
You can share the sound from your.
Oh, okay. I'll have to change the shares. I think I know what to do. Okay. What?
The entire land mass makes up about 29% of the Earth's surface area. So although in truth, they're tapping into only a small fraction of what's available. But that's quickly changing. Let's take a look at how companies around the world are taking wind energy captured at sea and channeling it back to land and into our homes. And at how these marvelous machines are capable of much more than meets the eye. Offshore turbines are, from the waist up, practically identical to their counterparts on land, with one fairly obvious difference: they're typically bigger. The tallest onshore turbine in the U.S., for example, stands at a height of about 574 feet. The offshore Halade X by GE, meanwhile, is a whopping 853 feet tall. That's nearly three turbines onshore and off are pretty much the same. The energy carried by wind turns 2 or 3 propeller-like blades around a rotor. That rotor then turns the main shaft. This low-speed shaft spins at the same speed as the blades, about 7 to 12 turns per minute. A gearbox boosts speed into ultra-rated on land. Here's where things get interesting. Wind turbines are almost never built as standalone structures. They are built in arrays, called wind farms, to harvest as much energy as possible. But not all turbines on an offshore wind farm feed into a substation. Turbines are strung together in bundles of about 8. Cables running between turbines feed electrical energy from the outermost structure to the next innermost structure, then to the next, and the next, and the next, until all of that energy finally reaches the substation. The substation collects all the electricity shuttled through this energy brigade and ultimately.
Perhaps you guys are hearing the video, right? Just showing that when you have all these offshore wind turbines, right, it generates a lot of electricity, which is just a very costly setup to actually get the electricity back to the land. So I'm gonna just go and start the first question. Okay. So yeah, so the question is, what is one benefit and disadvantages of wind turbines, right? So I just want you to write your name and just write a benefit and a disadvantage there, and it will just all pop up on the screen. Maybe you get about 2 minutes. Anything too complex, it could be a very simple observation, one benefit, one disadvantage, depending. Can you guys 1 more minute? Yeah. You for the responses here. You can keep answering. I'm gonna just talk about a couple of these. So from here, let's see, we have one from CM Home. So operation at night is a very important benefit, as like other, not all of renewables can always operate at night. We have some disadvantages such as not constant, and um it's not very constant because it emits an intermittent style of renewable energies, and that's a very important disadvantage. But because of time, I'm just gonna go on to the next video.
Tidal power. Tidal power is a form of hydropower that converts the energy from the natural rise and fall of the tides into electricity. Tides are caused by the combined effects of gravitational forces exerted by the moon, the sun, and the rotation of the earth. Tidal plants can only be installed along coastlines. Coastlines often experience 2 high tides and 2 low tides on a daily basis. The difference in water levels must be at least 5 meters high to produce electricity. Tidal electricity can be created from several technologies, the main ones being tidal barrages, tidal fences, and tidal turbines. Tidal barrages are the most efficient tidal energy sources. A tidal barrage is a dam that utilizes the potential energy generated by the change in height between high and low tides. This energy turns a turbine or compresses air, which in turn creates electricity. Tidal fences are turbines that operate like giant turnstiles, whereas tidal turbines are similar to wind turbines, only underwater. In both cases, electricity is generated when the mechanical energy of tidal currents turns turbines connected to a generator. The generator produces electricity. Ocean currents generate relatively more.
Let's go through that with everyone. Um, let's just move on to our next question. So could everyone just write down a quick disadvantage and benefit of tidal energy? And I'll just choose one of the responses. Give you guys about 3 minutes for that. Is Gion Kim here? Could you just explain a bit more of your answer? I just wanted to hear your thoughts. I thought your comment was interesting, especially Abiba Khan's. Just curious.
Um, for pros, I said tidal patterns are more predictable than like solar panels, wind energy, as it's easy to see what time the high waves come in and the low waves go out from your weather app. Very predictable. So you can actually create how much energy that can be produced that day. So then it'll be easier to find a way to use the energy. So it will kind of be better with the intermittency of other renewable energy sources. And for the cons, they said high initial costs because so for building a tidal energy plant, so you have to build something that looks like a dam. So it's more complicated and it has more capital costs, initial capital costs than wind farms or solar panels. So and also a big environmental impact because I don't know what to call it in English, but the place where the tides go out, it's a big habitat for a lot of sea animals. It might damage in a way.
Okay, thank you for your answer. Does anyone else want to join a response? We'll just continue on to the last one. Do a quick video. This is from a specific wave energy. Let's see.
커피가 맛없는데
Core Power's wave energy converters harness clean energy from the world's largest untapped energy source, our oceans. Energy stored in ocean waves is absorbed at the surface by a heaving buoy. Inspired by the pumping principle of the human heart, the wave energy technology is informed by 40 years of hydrodynamic research, allowing for a lightweight and low-cost design that maximizes generation capacity and provides robust operation in the harshest ocean conditions. The wave energy is used to create rotational motion, which is
one form of wind energy. Like I said, just one company approaches utilize harnessing wave energy. There's another company that uses this like giant yellow like platform that moves along with the wave. And I believe it does something very similar. And I believe it's actually in production in the US currently. But let's just get on to the Q&A. And I'll spend a lot of time. Now, the last one, same setup, but just for wave energy. I'll give you guys about 3 minutes. Right, simplicity. Okay, one or two more responses before I stop. Does anyone want to hear response? I think if you don't want, it's fine. I'll just skip ahead to the end. So, okay, so just a very interesting question. Could you guys just like tell me what like your favorite type of renewable energy from three we discussed today is? It should be on the same screen. Oh, competition. It's almost all tied up. I'll give you guys just one more minute. Then I'll just ask someone as a representative to explain their thoughts and views. So I'm not gonna get any more responses. So does anyone just want to defend their claim as to why they believe their energy type is the best? No? Yes, that's it. Then I'll just call the presentation here and thank you everyone for listening to my presentation. I apologize for the technical difficulties, but that's it.
Final.
Recording in progress. Samsung, and is about ocean renewable energy, sector three, and lecture three is about current and thermal energy. So, this table is about the power density of some energy source. Gas and coal is very high energy power density, about watt per meter square, and solar or wind energy is very low power density compared to gas and coal. But this table is about the joule per cubic meters about the power source, and solar radiation is very low, have very low power efficiency, and but the geothermal energy and wind and tidal energies have higher power. The lower table is about the energy source and cost efficiency about energy source, and actually this table is from the nuclear energy. Is about the nuclear energy have the lower higher cost efficiency, but as you can see, the biomass and geothermal energy and wind onshore energy is much higher cost efficiency compared to other energy sources. So, current or wind energy, geothermal energy is have nice cost efficiency. So let's talk about current energy. Current energy. What is ocean current? Ocean current have two types of currents. First one is surface current, and second one is deep ocean current. Surface current is driven by the wind, as you know. Is the surface current, and the wind makes flow on the surface of the ocean, and the water drags the lower water and drags the lower water continues. So the wind effect upper 400 meters in depth, and it is about 100 meters depth is effective mainly about the from the wind. So this is surface current, and other one is deep ocean currents. Is not affected by the wind because it's so too deep. So that kind of currents driven by the density and temperature gradients. It makes a global conveyor belt. You can see the conveyor belt in next slide. This is worldwide deep ocean conveyor belt, and the red one is warm water and blue one is cold water. The conveyor belt can redistribute the heat in the earth from near the low widow from okay, sorry. Let's see the detail about the ocean current.
In 1992, a cargo ship carrying bath toys got caught in a storm. Shipping containers washed overboard, and the waves swept 28,000 rubber ducks and other toys into the North Pacific. But they didn't stick together. Quite the opposite. The ducks have since washed up all over the world, and researchers have used their paths to chart a better understanding of ocean currents. Ocean currents are driven by a range of sources: the wind, tides, changes in water density, and the rotation of the Earth. The topography of the ocean floor and the shoreline change direction. Ocean currents fall into two main categories: surface currents and deep ocean currents. Surface currents control the motion of the top 10% of the ocean's water, while deep ocean currents mobilize the other 90%. Though they have different causes, surface and deep ocean currents influence each other in an intricate dance that keeps the entire ocean moving. Near the shore, surface currents are driven by both the wind and tides, which draw water back and forth as the water level falls and rises. Meanwhile, in the open ocean, wind is the major force behind surface currents. As wind blows over the ocean, it drags the top layers of water along with it. That moving water pulls on the layers underneath, and those pull on the ones beneath them. In fact, water as deep as 400 meters is still affected by the wind at the ocean's surface. If you zoom out to look at the patterns of surface currents all over the Earth, you'll see that they form big loops called gyres, which travel clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. That's because of the way the Earth's rotation affects the wind patterns that give rise to these currents. If the Earth didn't rotate, air and water would simply move back and forth between low pressure at the equator and high pressure at the poles. But as the Earth spins, air moving from the equator to the North Pole is deflected eastward, and air moving back down is deflected westward. The mirror image happens in the southern hemisphere, so that the major streams of wind form loop-like patterns around the ocean basins. This is called the Coriolis effect. The winds push the ocean beneath them into the same rotating gyres, and because water holds onto heat more effectively than air, these currents help redistribute warmth around the globe. Unlike surface currents, deep ocean currents are driven primarily by changes in the density of seawater. As water moves towards the North Pole, it gets colder. It also has a higher concentration of salt, because the ice crystals that form trap water while leaving salt behind. This cold, salty water is more dense, so it sinks, and warmer surface water takes its place, setting up a vertical current called thermohaline circulation. Thermohaline circulation of deep water and wind-driven surface currents combine to form a winding loop called the global conveyor belt. As water moves from the depths of the ocean to the surface, it carries nutrients that nourish the microorganisms which form the base of many ocean food chains. The global conveyor belt is the longest current in the world, snaking all around the globe, but it only moves a few centimeters per second. It could take a drop of water 1,000 years to make the full trip. However, rising sea temperatures are causing the conveyor belt to seemingly slow down. Models show this causing havoc with weather systems on both.
And so the current energy is have the ocean currents have energy potential, and in ocean current, as you hear the video in the video, it's very slow compared to other surface current or wind. But the ocean currents have 8,000, right? 800 times as dense as air, so it is slow but it's powerful. So, for instance, the 12 mile per second ocean current would have an energy output equal or greater to the 112 mile per second wind. And the Mercury stream is kind of a huge current in the near the U.S. 1/1000 of energy of the Mercury stream can satisfy the 35% of Florida's energy need. So current energy is very powerful. And crucial, you guys, many of you guys heard crucial current in your middle school side, high school. And it's near Japan current, gyro. And this is how the current on the ocean looks like, but I'll skip this video. It's only this picture. And next is how can we utilize the current energy? It's very similar to the wind turbine. It looks almost same, but just put this in deep water. So there are two types of wind turbines, horizontal and vertical, but the principle is almost same. Just rotate the fan and make electric. So I'll skip this. And this is one of the example of the water turbine in the Japan, Nagasaki. It can make 2 megawatts and diameter is 60 meters long and height 27 meters long. And it rotates slowly, but makes powerful many energy. And this is about near US current, but you can see the Gulf Stream here, mentioned before. It's powerful stream, but I will skip this. It's not that important, I think. Short video.
We hear about strange things from distant places being washed up on our shores all the time, but how do they get there? Ocean currents are the movements of surface water in the oceans. Their direction is influenced by many factors, including the rotation of the Earth, the size and shapes of the continents. Ocean currents caused by prevailing winds are called drift, and in the southern hemisphere, the currents are anti-clockwise. Currents originating from the polar regions carry cold water. There's the California current, the Peru or Humboldt current, the Labrador, Canaries, Benguela, the Antarctic circumpolar currents, and the Oyashio. Currents originating from the equatorial, the Brazil current, the North and South equatorial currents, and the Kuroshio. So perhaps it's not so surprising that many of the items that are washed ashore originate from far-off places, thousands of miles away.
One is thermal energy. The thermal energy is usual thermal energy and ocean thermal energy converted. Two types of thermal energy. The left one is the geothermal energy and right one is OTEC energy. Use about OTEC energy. You use about
oceans to produce clean electricity, day and night and all year round. This is called Ocean Thermal Energy Conversion, or OTEC. It works best in the tropical equatorial zone. Here the ocean temperature difference is at least 20 degrees Celsius throughout the year. How does it work? The ocean's warm surface water vaporizes a working fluid with a low boiling point. ammonia for example. The vapor expands and spins a turbine that is coupled to a generator that produces electricity. The vapor is then cooled by cold, deep seawater. That way, the working fluid condenses back into a liquid and you can reuse it. This makes it a continuous electricity generating cycle. OTEC can become an important renewable energy source. At Delft University of Technology, we do research to try and make this happen. For example, by helping to develop offshore technology and process equipment for OTEC. If you want to find out more about ocean energy, go to the Delft University of Technology Ocean Energy website.
Next plan have two layers, upper layer and lower layer. Upper one heated by the solar energy, and lower one is the cold water from the cooler region. So it have natural temperature gradient, and OTEC uses this natural energy thermal gradient. So it can generate electricity. And next one is geothermal energy. Geothermal energy, I think most of you guys took the thermodynamics course, and it's same principle. Just use another source, just the geothermal upper part of the OTEC plant was changed into the deep hot dry wax. So sun energy changed to hot dry wax, and other things are most similar. So I think I can skip this. Okay. That's it. Thank you.
Great. It's some videos. Great. So, there were more discussion. Okay. Come
Yeah, but like,
What's
misuse. I don't have no idea about. I can just join a good meeting and appreciate it. And that's some shooting. Anybody? Hope you guys remember me. Yeah, I'm in charge of the discussion session. But I created this slice based on the last list material, so I've like and I realized like I have no hot water thermal energy. We have smooth elements, hot energy. And that's pretty much easy. So yeah. So how many percentage do we need for solar energy to meet global energy usage? Quick calculation. Anybody can do a calculation. You just try it out. 2%. Okay. So here we have okay. Solar and the global usage. The result is only this one, less than 2%. Yeah. Okay. Yeah, maybe everybody don't know about the name, so I'll just show you the answer because we don't have the lecture for this part. And then I'm going to talk about the number 3 and 4 active solar and the passive solar. So we just remember the name for each. Okay. Yeah. Does anybody know what are the features of 5 elements? Maybe I guess no, because we have no lectures for it. Does anyone have any background knowledge for these? You guys have the solar panels in your house? No? Okay, all right. Yeah, that's smart. So collectors, it's a windows that sunlight can go through it, and then absorber is a dark surface that can easily absorb, the lights so to the mainly the black side. And the thermal mass is materials that can store the heat and distribution. It's something to make use and also control modules lens. These are 5 features, main 5 features. So I'll just quickly show you the pros and cons of constant solar heating. Pros are simplicity and energy efficiency, lower initial costs, and durability. Okay, and the cons are one is limited controls, and the second one is dependence of design and reliability. Just quickly, because we have not much time. So this is the active one, not the passive one. So what do you think? What are the necessary components for active solar heating? Maybe, yeah, it might be really small, but you can see from from pictures. Okay, no difference from the passive one. One is solar collector. It's a dark color plate, yeah, same as the passive one. And the pump is circulate the fluid. Okay, and the fluid carries heat. And heat exchanger is exchange the heat to heat to warm the house, just like Korean what name, but you guys have a heaters. Honor, yeah. Thanks so much. Yeah. And last one is radiators. It's emit the heat to warm up the house. Okay. Sure. So multi-solar heaters pros and cons. The advantage, one advantage is efficiency and greater control, and also heat storage. And at once complexity, high cost, energy consumption, and also it's really hard to maintenance. Okay, well, this is pretty much easy. So you guys can answer. So why tracking the sun is important? Why do we have to check the sun? Yeah,
For the best efficiency.
yeah, but why you can get the best efficiency when you track the sun?
The sun,
Yeah, true. It's elementary school's question. Thank you so much. Yeah, because the sun keeps moving, right? Yeah. Thank you. And yeah, determining is no the yeah elementary one. So the different difficulties is no the different. So principle is we can convert solar lights directly into the electricity. So like compared to what's that? Lighting compound. You know, technology, for example, like what's that? What's the name? The wind power, and also the water and the nuclear. They all avoid the water and then spin the turbine. It's the main principle. But solar, we have no turbine. We have just sunlight and then we can directly convert it to electricity. So this is a different principle compared to other technology. Let's watch this video and just think about it. I'll just ask you the question. This one, what do we have to consider when we want to use solar energy in the ocean or in the or in the water? I'll just show you the video. So the audio. Here the audio. This video, so it's not so long.
Ocean Sun, a bold solution to our global energy needs. The world is in need of clean energy. In recent years, solar power has proven itself to be the most efficient source. Yet, in order to produce large amounts of energy, solar power plants require vast areas of land. Sufficient land areas cannot be found near the densely populated places where power is consumed, and agricultural and recreational spaces cannot be sacrificed. This results in substantial transmission costs from the power plant to the consumer. Around the globe, most people and most large cities are located in coastal areas with the open ocean right on their doorstep. Using Ocean Sun's solution, combined with large free areas of the sea, we can obtain clean and cost-effective renewable energy production close to populated areas. The power plants can be conveniently positioned out of sight and with transmission cables placed on the seabed. The direct cooling effect of the ocean greatly increases energy production, making ocean sun plants more cost-effective than land-based installations. They have also been designed to withstand harsh offshore weather conditions. Ocean Sun now successfully operates several prototypes on the west coast of Norway. This area offers a wide range of sea conditions, ideal for further development. The hydroelastic membrane has a proven capacity to reduce wave impact and offers a protective environment for the solar modules. Ocean Sun's patented solution is based on marinized modules of commodity crystalline silicon solar cells. The modules rest on a thin membrane, offering low-cost deployment and easy access. The system is built with durable materials founded on world-class maritime and aluminium know-how. The next step will be city-scale installations. In the quest for widespread renewable energy, we dare to say that we have the solution.
Question: what do you have to consider when we want to use solar energy in the ocean? What's our problem? What's the you have to care about? Oh, yeah.
Oh, sorry. Yeah, salt water like destroys like everything.
Yeah, true. That's the one concerns. Yeah, correct. What else? What else do you have?
Okay.
Yep. Yeah. The salt water, this one is most concerned. Yeah, we use in the ocean, and also we have to make floating solar panels, and also we have to care about transmission. We have to repair the long cable and also the draws. Right. And yeah, we're just thinking about showing you this video, but it's not much. Yeah, you can just think about the bioresources without daily knowledge. So how can we use bioenergy? Or how can we convert, yeah, bioresources into living? What kind of fuel, what kind of things we make from the bioresources? So we usually make the biogas and also bioethanol, right? Maybe there are some cars or the ships that use the bioethanol. And also we have a biodiesel. Yes, okay. These boards are main usage of the bioenergy resources. Okay. So this is the pros and cons of bioenergy in ocean. The pros, the advantage is carbon sequence and also the diverse fuel types, the ethanol, the biomass, and also reduce freshwater usage. But a disadvantage, the one is challenge in seaweed farming. Yeah, this one is pretty much difficult. It's also hard, like seaweed for food. Yeah, and also unpredictable growth rates. Yeah, and then the third one is nutrient and pollution concerns. Seaweeds also pollutes, sometimes pollute the ocean, so we also have to care about this. Right. Yeah, that's it for today. Yeah, thank you so much, everybody. I'm waiting for 10 minutes, right? Thanks so much.
And next week there will be a guest lecture on Tuesday. And Thursday will be the last lesson. Lecturing discussion. Then finally. Any questions? No? See you next week. Yes.